Even myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. So in today's class, we are going to incorporate design thinking concept in normal forms of logics. So which is one of the topic in discrete mathematics. Okay. So first we are going to see what is mean by a design thinking, then how we need to integrate this design thinking in our concept. Okay. So integrating design thinking into the normal forms of logic such as conjunctive normal form and disjunctive normal form involves applying a user-centered iterative approach to the formalization, simplification, and problem-solving processes inherent in logical expressions. Here is how you can bring design thinking into working with normal forms of logic. So first we need to empathize. So for that we need to understand the problem context, identify the stakeholders, begin by understanding who will use or be affected by the logical expressions. For instance, if you are working on optimizing a database query which might be expressed in CNF or DNF, we are going to consider the needs of database administrators, users and the system itself. Now we are going to have the contextual inquiry, engage with the stakeholders to understand the problem domain, requirements and constraints. Ask questions like what are the key criteria for success or what issues are most critical to solve. Now we are going to have the second state which is define. So for that we need to frame the problem. So problem definition. So clearly we need to define the problem that the logical expression is trying to solve. For example, if you are optimizing a search algorithm, the problem might be how to minimize search time while ensuring accuracy. Goal articulation. Specify what a successful logical expression should achieve, such as reducing the complexity of an algorithm or making a decision-making process more transparent. Third step is ideate. So we are going to explore the possible logical structures. So brainstorm different forms, explore various logical structures that could meet the defined goals. For instance, consider whether CNF or DNF or other form like negation normal form best fits the problem at hand. Simplification strategies. Think creatively about how to simplify the logical expressions. This might involve using tools like Karnaugh maps, truth tables, or Boolean algebra to find minimal representations. Alternative approaches. Consider a non-traditional forms or hybrid approaches that might better address user needs or system constraints. Prototype. Develop logical expressions. So construct iterative models, develop initial versions of logical expressions in CNF or DNF, test these models with respect to the problem definition. For example, create a prototype query or decision-making algorithm. Iterative testing. Implement the logical forms in a simplified version of the actual system or process. Use simulations or small-scale tests to see how well the expressions work in practice. Test. So now we are going to validate the logical expressions. User feedback. So gather feedback from stakeholders on how the logical forms perform in real world scenarios. Do they meet the defined goals? Are they easy to understand and implement? Iterate based on results. Based on feedback, refine the logical expressions. This might involve simplifying the logic further, changing the form, example, from CNF to DNF, or even rethinking the problem definition. Now we are going to reflect and refine continuous improvement for our problem statement. So post-implementation review. After deploying the logical forms, conduct a review to see if they continue to meet your user needs and system requirements. Consider if further simplification or optimizations are possible. Documentation and knowledge sharing. Document the process, decisions and outcomes. Share insights with the broader team to foster a culture of continuous learning and improvement. Example. So applying design thinking to a logical problem. So imagine you are optimizing a database query that involves multiple conditions. Initially, the query is expressed in DNF, but it's too complex and slow. Applying design thinking, empathize, you consult with database users who need faster query responses. Define. The problem is defined as optimizing query speed without sacrificing the accuracy. Ideate. You brainstorm using CNF, exploring various ways to restructure the logic to reduce processing time. Prototype. You develop a CNF version of the query and test it with a subset of the database. Test. Users test the new query and provide feedback on its performance. Now we are going to reflect. So you refine the CNF further based on feedback, achieving a balance between speed and accuracy. By incorporating design thinking, you ensure that the logical expressions in normal forms are not only theoretically sound but also practical, user friendly, and aligned with real world needs. So, thank you.